Welcome to General Chemistry Mini Lecture Series, Lecture 3, Classification and Property of Matter. So first we'll talk about property of matter. Start with a chemical property. So chemical properties describe how substances react or change to form different substances. Okay, so the identity of the substance is changed. That's the chemical property. We can take hydrogen and oxygen as an example. If those two react together, the burning process will occur, and then you will not see hydrogen or oxygen molecules anymore. Instead, you will see CO2 and water. So that's chemical properties. On the other hand, physical properties can be measured without changing the identity of the substances. What can be some of the physical properties? For example, the color of your shirt, density of water, melting point of a solid, and so on and so forth. So those are just physical properties. The identity of the substance is not affected, it's not changed by those physical properties. Now let's take another side of properties. The first one here is intensive physical properties. So they do not depend on how much the substance is present. For example, the density of water doesn't matter you have 1 cup of water or 1 gallon of water. The density of water should be the same if you get them from the same source. So around 1 gram per milliliter. Extensive physical properties do depend upon the amount of substance present. For example, mass. The mass of 1 cup of water is much, much smaller than the mass of 1 gallon of water. Volume is the same. So therefore, that's intensive physical properties and extensive physical properties. And sometimes we just say intensive properties, extensive properties, but both are physical properties, not chemical properties. Yeah, let's work on a few problems. Classify each property as a physical or chemical. A, the tendency of ethyl alcohol to burn. Burning, that's actually oxidation reaction. So therefore, that's a chemical property. So ethanol, after burning, you don't see any ethanol anymore. The identity is changed. So you will have CO2 and water. The shine of silver. Silver is metal. It has a shining color. That property, is that chemical or physical? It is a physical property because it's still silver. The odor of paint thinner, so the smell, is that a chemical or physical property? Again, we have to concentrate on whether the identity of the substance can be changed. So it cannot be changed. So the paint is there. There's no identity change. It's still the same paint material. It just smells. It just has certain odor. So that's physical property. The flammability of propane gas. What does it mean? It means the ability to burn. And again, burning, that means actually chemical reaction. That's an oxidation reaction. So therefore, that's a chemical property. Okay, let's talk about the changes in matter. Physical changes. So physical changes only alter the state or appearance of the matter without altering the composition. The composition means identity. So all of those phase changes we learned in previous lectures, like from solid to liquid, from liquid to gases, those are all physical changes. Chemical changes do alter the composition of the matter. For example, during the chemical change, the atoms that are present rearrange into new molecules. But all of the original atoms are still there. For example, hydrogen reacting with oxygen molecules forming water. So balance it. So before the reaction, we have a hydrogen molecule, H2, and oxygen molecule, O2. Then after the reaction, you don't see H2 or O2 anymore. You see H2O. So the atoms are rearranged. Before the reaction, you have 4 hydrogen atoms. After the reaction, you still have 4, only they are rearranged. So before reaction, you have 2 oxygen atoms. After the reaction, you have also 2. And again, they are just got rearranged. That's what I meant here. Let's work on additional problems. Determine whether each of the following statements describes a physical or chemical change. A match ignites after being struck on a flint. After this action, you know the original match will burn, which means the identity of that material there is changed. So therefore, this is a chemical change. Dry ice vaporizes into the gas phase. So dry ice is CO2. If you pull that out and place that in the room temperature, so you will just see CO2 gases, fume, comes out. The identity of CO2 is not changed. It's only the physical state changed from solid to gas. So therefore, that's physical change. A nickel dissolves in acid to form a blue-green solution. What's the state of nickel? That's solid. And what's the state of the solution? That's liquid. You see, that's just phase change. No, not really. Yes, the phase change, but actually there is a chemical reaction going on. So the acid oxidizes nickel. Okay, so the nickel here actually in nickel atoms. And then the nickel here in the solution is cation ions. So that's a chemical change. It's not the same identity anymore. Okay, so that's nickel atom, and here are nickel cation ions. They are not the same. A copper wire is hammered flat. Okay, again the shape change, but it's a chemical property change. It's the identity change. Before you hammer it, and after you hammer a piece of a copper wire, the identity of that material doesn't change. If it doesn't change, that's physical change. Only change the state, the shape. Now let's go through this summary slide. This is a very useful one. Classification of matter. We start with matter, okay? So matter is anything that occupies space and has a mass. So first, let's ask this question. Does the matter have variable composition? If it does not, then that's just pure substances. Pure substances are made of one type of particle, just one type of particle. And all samples show the same intensive properties. If the composition of a matter is variable, then you have a mixture. So mixtures are made of more than one type of particles. And the samples may show different intensive properties, which means the identity of each substance in the mixture is different. Now go back to pure substance. If we ask, can the pure substances be decomposed into other substances by chemical process? If the answer is no, which means the pure substance cannot be decomposed into other substances, then those pure substances, they are just elements. What are elements? You can find all of the elements in a copy of periodic table plus those diatomic molecules. So there are typically these 7 diatomic molecules. They are classified as an element. If the pure substance can be decomposed into other substances by chemical processes, then those are called compounds. For example, water can be decomposed into hydrogen and oxygen. So they are compounds. They are not elements. There are 2 different types of mixtures as well. if we concentrate on the uniformity, if the mixture is uniform throughout, then that will be homogeneous mixture. If it's not, that will be heterogeneous mixture. So let's talk about heterogeneous mixture. So which means this mixture is not uniform throughout. What are the examples? Let's say you love a salad. You go to the dining hall and what find in salad? That's heterogeneous mixture. You have dressing, you have lettuce, you have maybe cucumber, tomato. So that's a mix, okay? It's not uniform. Cereal in milk. Milk is liquid, cereal is solid. Even you have two liquid, let's say oil in water. Some of you probably had the experience of cooking, just simply making a soup. So you start with some cooking oil and then you add water. What do you see? You see the oil flake on top of the water. Therefore, it's not uniform throughout. Now, how about homogeneous mixture? So they are uniform throughout. Just by appearance, you could not tell the difference. So if you add, for example, sugar into water and it's fully dissolved, you don't have excess solid sugar in there. So then that mixture is homogeneous mixture. Cooking oil by itself, if it's not mixed with water, that's homogeneous mixture. Air, when we breathe, we know our body just takes oxygen in, but there are other gases in the air. So therefore, air is a homogeneous mixture. Of course, you can have solid homogeneous mixture like steel. It contains mainly iron and then some other metals there. Again, this is a very helpful summary slide about matter. Okay, let's work on this problem. Classify each substance as a pure substance or a mixture. If it is a pure substance, classify it as an element or compound. If it is a mixture, classify it as homogeneous or heterogeneous mixture. Okay, salt water. So here the salt water, I'm not talking about the ocean water. I'm just simply talking about the water you make by adding table salt, nothing else. Then that's homogeneous mixture because all of the sodium chloride is dissolved in water. Everywhere the same. Carbon monoxide, obviously, there's just one identity, which is carbon monoxide, CO, and therefore it's pure substance, iron. So from a copy of periodic table, you know that's an element, therefore it has to be pure substance. Vegetable soup, obviously, that's heterogeneous mixture. So if there are mixtures, then there are actually ways to separate the mixtures. Here I'm talking about the separation based on physical properties. So there I listed a few techniques, and here are the mechanisms. So how it works. Okay, first one, distillation. Of course, we take the advantage of boiling point. The one with the lower boiling point get vaporized at a lower temperature, becomes, of course, gases, and then you condense that, then you have the pure substance, and the one with a higher boiling point still remains as a liquid. That's why you get them separated. Evaporation, that's based on volatility. Filtration, based on the state of matter, solid, liquid, or gas, and also the size of the particles. Centrifugation, that's based on the density. Chromatography, some of you will learn that later on. That's based on adsorption and absorption. Okay, so those are the different techniques for separation of mixtures based on those physical properties. Now let's take a look at this end of lecture quizzes. So let's work on number 1 together. The image to the right represents which of the following? Okay, the image to the right. What do I see? I see molecules, 6 molecules. Before you answer the question, you should read those choices. A gaseous pure substance. B, a liquid pure substance. C, gaseous mixture. D, solid mixture. Okay, we have substance and we have mixture. By looking at this depiction, or this picture, I only see pure substance because that's all just one atom of one element, two atoms of another element, all right? And that's 6 identical molecules right here. So therefore, that cannot be a mixture. So therefore, I know the answer has to be A or B. Now the question is the physical state. Is this gaseous state or liquid state? You can answer that with the density. And this tells me the density is very low. If it were in liquid, you will see those individual molecules almost like attached to each other, pretty dense. But in gas, we know gas is very light. The density is very low. So therefore, to me, it seems it's a gaseous pure substance. So therefore, the correct answer should be A. Okay. And of course, you guys will work on number 2, number 3, and many more, again, from other sources. Most importantly, of course, work on the homework problems. So this is lecture 3, and we'll see you guys in lecture 4.